Muhammad Junaid Hassan, PhD in Artificial Intelligence Technique. Sir is specialized in developing advanced machine learning algorithms with explainable AI methods. His research interest includes the data-driven fault diagnosis, condition monitoring, and anomaly detection of complex engineering systems. Research extends to fields of advanced signal processing, and image processing. Mr. Hassan received the Best Researcher Award for 3 consecutive years from 2019 to 21 for his outstanding contribution towards the research community from University of Ulsan, Republic of Korea. He has 10 scientific articles from reputed journals such as Elsewhere, MDPI, IEEE Access with SCI, and SCIE indexing, and 3 book chapters from Springer. Currently, Sir is working as a machine learning research scientist of Ulsan Industrial Artificial Laboratory, Republic of Korea from last 4 years. He had previous experiences in developing advanced gaming techniques and user interface designs. Has collaborated with intrinsic science labs in developing product like factory optimization techniques. So thank you, sir. It's a privilege to have you here, sir. Um, we can start the session, sir.
Okay. Thanks a lot for the great introduction and good day. Thanks for having me.
Yeah, thank you, sir. Thanks a lot.
Yeah, so it's been an honor over here and also a little bit talk about myself. But before that, let me share the screen.
Sure, sir, sure.
Okay. I think. Okay. Okay. So I think it's visible, right?
Yes, sir, yes.
It's okay. Sure. So today I want to talk about the necessities of explainable artificial intelligence for developing efficient machine learning models for bearing fault diagnosis. And about myself, already the host and the organizer introduced about me. Thanks a lot for that. And this is my email address I have included in the presentation. So for from my presentation, if anyone has any question or something you need for future, you can email to me and I will reply back. Also, today I will not go into very deeper procedures about how we do that, how we did that, this type of thing. Rather, I will talk about the basic necessities of explainable AI for developing the bearing fault diagnosis models. So, as the main focus is explainable AI, however, the example I picked up that is bearing fault diagnosis because out of many areas I was working with, bearing is one of them, and that is why I picked up this application. So first thing first is bearing. Very basic question is like, where do we see the bearing? Mostly to give a very intuitive idea, this bearing we see like in the car front wheel, you see, or the back wheel, wherever. So if here are students, for them it is easier for visualization. Also, some kind of rotatory machineries. Rotatory machineries means like those machines usually like rotate like this, like this. So it is like clockwise or anti-clockwise, it usually rotates. So this is the rotating machineries and bearing is one of them. And so these are the structure of the bearing. So why actually we do need to uh, diagnose this bearing? Because as you know, the car always runs into the road. We suppose we are in a car and it is moving, and if something happens problem over here, so it is actually a problem for our life death situation also. Also, sometimes you may see like into the industry, there are a lot of heavy motors. So these motors has this bearing inside into it. So this is a part of mechanical systems. However, I am not going to talk about those, but to tackle this issue, to ensure the human life, we need to understand like why this bearing has certain difficulties and how we can solve it. And we need to inform the user like, okay, hey, your car has this problem into bearing and you need to change that. This type of problem is occurring due to this part has some issues, right? So for that reason, we need to go for the bearing fault diagnosis. So there are several techniques to do this bearing fault diagnosis. Previously, not previously, still now also, one part is signal processing we do. Why signal processing we do? Because this is a bearing, and this bearing directly we cannot tell okay what is the problem or what is not the problem. So how we do is somehow you can think okay, this is a bearing, and into the setup we somehow attach some kind of sensor into it. This is a pictorial view, intuitive way, not the perfect way. So we collect some kind of signal from it. Okay, so different types of signals. So in the normal condition, when the bearing is perfect, that time the signal looks like maybe this. When it is abnormal, maybe sometimes of abnormalities we observe into the signal. Okay, this is abnormal. So this signal first we collect, and then we validate those data. This is another story, and then from this data, from this signal, we do some kind of signal processing. So it is you may think it is that data processing kind of a step, and then we find out the distinctive characteristics from these signals, and then we go for the identification or prediction or classification, this type of direction. So characteristics, suppose normal one does not have very much spikes, abnormal one you see here is a spikes I draw. So normal one maybe here, and abnormal one is the high peaks, right? So this is intuitive way of understanding. So these high peaks are kind of my characteristics for abnormal, and low peaks are the characteristics for normal. These characteristics in short term we tell features. Okay, so we extract these features and then pass to the different types of AI based methods, machine learning or deep learning, and then we classify. This is the simple structure. So for that, in recent days or maybe 10 years ago, we started to use extensively machine learning from 2017. A lot of methodologies are coming into game and we are using those extensively. So just a moment, please. Okay. So now let's go to the machine learning module and deep learning module. What is these and how we are doing that? So as I told, from input, we first extract the features. Input means those signals from bearing, and then we do classification, and then we do like, okay, how will be the output? So here in the example, we are trying to identify is it a car or not a car. So if it is a car, some type of features we extract, and then we do the classification. We pass those features to the classifier, and then we get the output. For deep learning case, the part is this feature extraction are not manual, right? So deep learning based architecture usually like extract these features automatically and gives the output directly. However, there is a problem. This problem is, suppose in our previous example, I already mentioned, okay, these low peaks are from normal and these high peaks are from abnormal. This decision we give based on our human expertise. So when some feature extractor comes into play, we think, okay, this might be the features and this might not be the features based on some statistical analysis. And we tell, okay, these are the features. And from our human intuitive way, we can tell, okay, these features are very important and these features are not very important. And then we see different types of algorithms, how they come into decision. And then we pass to the classifier. However, you may think, okay, a story that is, suppose to a child. I tell, okay, this is a cat. And the child say, okay, it is a cat. I told that child, okay, this is a cat because it has some whisker and it has some ear. That is why it is a cat. I told the child about this thing. However, the child can successfully identify whether it is a cat or some other animal, but we don't know whether the child is also thinking like me, okay, this is the whisker and this is the ear. Maybe it can see the cat and listen to the sound it is doing, like meow, but this type of sound, and it can tell it is a cat. So we actually don't guarantee the child is also telling in the same direction, like I have instructed to him or her, like this is a cat in that direction, in that way. So we cannot actually say, okay, as I instructed the child, okay, because it has whisker and it has ear, that is why it is cat. It might think, it might infer to a certain decision based on its own understanding. So the classification algorithm has this issue. We tell, okay, these are the highest peaks and these are the maybe lowest peak. So when we are doing this manual, a machine learning classifier, maybe it can take the decision based on my giving input. However, when the deep learning based solution comes, as it extracted the features automatically, so we cannot tell exactly. So these highest peak or lowest peak, these thing it take into consideration, or maybe the peak shape it also can take into consideration. We are not sure. So the thing is, into the industry, we can deploy a model and directly go. However, how can we validate the human interpretation? Or how can we say, okay, I told to that child, okay, the cat has whisker or cat has ear. And the child also should make the decision based on these two things. Then only I can trust the child. And for future, I can also give it direction because this is a matter of fact. Also, another thing is this thing I should clarify first stage, that is, it has ear, it has whisker. That does not mean these two things make it cat. So I told these are the two things, but it does not mean these two things are making it cat. Also, the sound and other factors are there. So we are giving reasons, we are giving explanations. That does not mean these explanations make it a cat. So this explanation is not creating the causality, right? So, but this part is doing only one thing, that is what we think that is also thought by machine. So thought by machine. So in that way, we can bring some type of trust and transparency. So this transparency currently most of those methods is not there. So we are telling this a black box algorithm. Give input, we get the output. So this black box now, as I told, maybe there are a few other factors. Suppose, as I told, the cat. So the cat not only has those ears, it has whiskers, maybe it has eyes, maybe it has mouth, maybe it has fur into the body, it has four legs, it has one tail. It is beautiful, okay? So there are a lot of characteristics into it. So when we do manual feature extraction, we first extract all those features important. I am going into the cat example because bearing it has data as a form of signal. So you can imagine the cat with the signal. But I'm giving the example of cat to give a generic overview to make it understandable, and my focus is to convey the message why we need the explainability. Then I'll go about that application part. So we extract a lot of features. Then there are different types of algorithms what will come and say, okay, this is a cat, but however, I think this cat whisker is the most important features. Maybe ear is the most important features. Maybe four legs are the most important features. Maybe the fur are the most important features. So the goal always is among all the characteristics or among all the features, we identify the most useful ones. And then from those most useful ones, when we identify, we create a selected feature set. So this step is called feature extraction. And this step is called feature selection. And then so these are the selected features. So feature selection, these two step is called feature selection. Okay, so after feature extraction and feature selection, we go for the final classification. We fed these features to some type of this black box, and then we get the output, right? So let's see. So okay, there are I want to talk about one technique that is for selecting these features, that is called genetic algorithm, evolutionary based computation. So genetic algorithm is basically a evolutionary based technique. In short, if we tell it this way, suppose this is the dinosaur and the dinosaur creates some generation, and based on the generation, which generation are best, those survived and go for reproduction and then mutation. In a very normal way, we can think, okay, as a human being, when we produce our next generation, we have to perform the biological behaviors and everything, and based on our chromosomal zonal activities, some chromosomes sustain, and from those chromosomes we produce the baby, and from father some genotypes are passing to the baby and then to the next generation, and as well from the predecessors. These things are in a cyclic way. However, in this way, if we select the feature from the feature set, okay, so full feature set from the cat, suppose my grandfather has a lot of characteristics into him, and my grandmother also a lot of characteristics into him, and however into her, and however all of those characteristics did not pass to my father, right? Why? Because based on this natural evolution selection mechanism, some sustained, some did not. But can we tell like why it sustained and why it did not? We cannot track that back actually. However, these are very popular techniques. We inspired through these, but the thing is, into our everyday usage right nowadays, we want to always know why certain characteristics we picked up. Suppose somebody told, okay, the cat has whisker. This is the most important thing. Why you picked only ear? This question cannot be answered through these genetic type algorithms or this type of algorithms. So there are some way to explain these things. Rather than evolutionary techniques, if we go into this decision tree based technique, suppose I showed an example for decision tree for loan approval. So as you see, the credit history we want to check, and we can tell, okay, whether good or bad income. So we can track to the good income, and then from credit history, if we go to the good income, we then track low or high. And then if low we want to go, then we can see a small or big. So how can we get the loan? By tracking this way. So in that way, when we infer any certain decision, then we can actually track back why we gave them loan, because the loan amount is small, income is low, and the credit history is good. That's why this person is getting the loan. However, in this case, if we use the genetic evolution technique, okay, to find out or give the decision whether a person is getting a loan or not, it was really impossible, and it would not be a fair judgment, right? So people will come and say, okay, randomly based on the selection evolution, this decision you gave, and the bank will be shut down. So this example I gave to bank because banking system, it is very important. However, for this diagnosis purpose or this classification purpose, nowadays this importance, the necessity of understanding why certain element has been picked up is very important, because into the real life when we deploy our algorithms, we sometimes suffer to this decision, like why certain decision has been made, because all the researchers around the world, even Myself also, when I was working till 2018 or 19, I used to think in that way. Okay, we extracted some features, then find out some great classifiers. It can give us 100% accuracy. But then the question comes: do you trust them? Do you trust your own decision? So we cannot, because it is not any spiritual segments to find out, like, okay, what we are doing and what we are not. And also, I gave one example of Dr. Strange. Here the chakra is there, so he can see the thousands and thousands of possibilities. But you know one thing, like, Lord, all the possibilities, if you want to shuffle up and see, it's also computationally expensive. Lot of time is required. So we cannot actually go through all the possibilities, because maybe if you have 5 features or 10 features, 10 characteristics, you can shuffle up all the possibilities and just see how evolution occurs. However, if you think we have like maybe thousands of features or thousands of similar features, or maybe tons of other characteristics, how we can make those combinations and go. So into the decision tree also, if you give, we can infer to some combinations. However, into the tree node, some combinations will have the matching element, so that we can come up with some solution and decision. So this way, actually, in the feature selector part, we can bring the explainability, and we can understand how certain features are uh, uh, come into play, or marked as important. But however, those features, suppose we say, okay, so features, maybe the whisker is the number 1 feature, and maybe the eyes are the number 2 feature from the cat, and then we pass those to the black box, and the black box will say, okay, this is a cat. However, the question is whether the black box also thought this whisker is the most important and the eye are the second most important, or it thinks, okay, it has eyes, that's why I'm telling it cat. That is why sometimes misclassification also happens, because for training time we are getting 100% accuracy, because when we have less amount of data, so how can it give us the certain decision? We actually cannot trust. So now let's talk about this thing. So I want to show with some diagram. Suppose you may say Messi CR7, and maybe some, I sorry, I'm not from India, but however, when I was a child, I remember one football player, Vutia, maybe. Please forgive me. Or maybe some Brazilian Star Kaká, maybe the Brazilian Ronaldo. These are the football players, and they are playing on football game. Okay, and other players are also there. So somebody come and say, okay, I am a Messi fan, and for Messi, this team wins. Somebody says, no, 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 I am CR7 fan, and for CR7, we own the football match. Okay, so we are just trying to justify how the performance of the match is going on, right? So how can we tell who is the most significant person over here? So I'm asking to the audience, whoever are listening to this session, can anybody please come up with some idea, like, we want to justify, okay, Messi is the best, or CR7 is the best in our football team, or Vutia is the best, or Kaka is the best, or Ronaldo, whoever. So how can you tell, like, who is the best one, and who is responsible mostly for our winning the game? Okay, so how can you tell? Can anybody come up with some idea and solution? I want to give some discussion. I want to have some discussion. Can anyone please? Hello? 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 Sorry, yes.
The
So
question is
can
for the audience.
yes. Yes, question is to the audience actually. So whoever are listening to this presentation, so my question is, uh, can anyone please tell me, like, how you can measure which player is the most effective one for winning the game. Hello? Am I audible?
Yeah, Junaid, you're audible, but probably no response from the audience.
Okay, okay, okay. Okay, so the thing is, uh, just for discussion, actually, okay, I'm getting into a discussion now. Suppose I remove Messi from my team and simulate the full game. And we, after simulating the full game, we gave some score. Okay, the score is suppose, sorry, the score is suppose we want to see. Okay, CR7 got maybe 30, Vutia got maybe 20, and again 25, 25. Now we bring Messi over here and we check, okay, when we brought Messi, how is this score is going to Messi? Maybe Messi also got 30. So CR7 and Messi still 30. So maybe Vutia got 10, Kaka got 15, and Ronaldo got 15. Maybe. We don't know. Okay. So the thing is, these are our players into the football game, and we are removing one player from the game and checking out how is the performance going on. Then again we keep that player into the game, and again we want to see how we perform the game, the score, how it is coming. So this way, if we mute one player, if we remove one player, kick out from the game and kept other players, we can see how the performance is there. And then when the player was there, we can compare it with it. We can compare when Messi was there. So this is the score maybe when Messi was there, and when the Messi was not there, this is the score after that, and we can calculate like, okay, how is the result? How is the difference is varying? So for each player in this way, we can vary. We can check if we remove one player, how the score has been distributed among all the players. Okay. So this thing actually has a name, and it is a basic principle for that. So this is called game theory. Okay. So in the game theory, we have several players. We tell, as I gave to the Messi, Ronaldo, and other players, and we see in the gambling game, all started into zero money, and then when A played, he earned $7, and then when we brought B into the game, so he earned $4, $7, and when C played $6. These are the individual scores. Then we actually try to mute one person from each time. So when B and A play together, they earn 7. That means A earned 7 and B and A together earn 7. That means actually A here B, there is no contribution from B, either one case, or another case is B earned 4. So if we minus 4, so that means earned 3 and B earned 4. So in the two cases, we saw the total score is highest for A, right? Because the first game A earned 7, and the second because B is 0, when we consider like A has 7 score. And when we consider from the B perspective, B earned score 4 and A earned 7. So we minus and we got 4 and 3. So for these two cases, B, the total score of B is 4 plus 0 is 4, and 7 plus 3 is 10. So definitely for two games, we saw like A has the most contribution. Okay. So in that way, we can rank these things. Okay. So intuitive way I'm telling this. However, this thing is more complex to explain, and for today's lecture, I do not want to go into so much complex details. Okay, so now let's understand. So these scoring techniques we call Shapley values. So Shapley values into the game theory is very important to understand how each player individually performs into the game. So this is the Shapley. Floyd Shapley invented these Shapley values, and Sir John Nash, he was the inventor of the game theory. So these two were inferred from economics, and as you see, nowadays we are moving towards a very multidisciplinary way of research. So as into the features. So now the question is how this game theory is relatable to the feature space. So each individual feature attribute you can tell as the player. Okay. So how each feature is performing, we can justify those things. However, it is not the feature selector part. We selected the features as I told before. Lot of permutation and combinations we need to make, and this much permutation and combinations we cannot make because of the computational uh, expense. So when we select certain features from all the feature sets, from thousands of feature sets, we select maybe 10 features. Then from these 10 features, we can shuffle up the things. Okay. And if we shuffle up the things, then actually life becomes a little bit easier. We get the explanations as well. And we also come into some decision, fair decision. So suppose here the mathematical intuitions we give. So S is the total feature subset, and M among it some feature subset we are picking up. As we told, like ABC was the players, and we are taking only two, or we're taking only one. These are the things it is doing. The performance is getting negation. We are doing minus performance, and then we are getting the score. So this is the way actually we are getting the uh, score. This is called the Shapley scoring techniques. So this is one way we can uh, see like how these things can be performed, or how we can ensure one certain decision we can get. Okay, so let's move to the next slide. Uh, okay. So again, I want to give some another example. This is also very important. So far, I have talked with the classification. So classification means I will draw a pictorial overview. Suppose, yes, this was that cat, 2 ears, whisker, body, tail, leg. Sorry, pardon me, the drawing is very bad. And then here we first select some lot of features. So those selected features are maybe ear, whisker, tail, leg, maybe fur, maybe sound, maybe breed, maybe color. These are the extracted features. Okay, now we need to select the features. So maybe with some explainable technique, maybe with the decision tree based technique, we come up with the feature selector, and we find out finally, okay, we kept whisker, we kept fur, we kept sound, and so whisker, fur, and sound. Now I have one question. Why you saw like whisker, fur, and sound. These three are the most important feature I have selected in a human intuitive way. Can anyone tell? Because from these all sort of feature sets, why we kept only these three? Uh, uh, in a human intuitive way, no need to go through the algorithmic way. Can anyone explain to me? Can anyone please tell to me from the audience? Can anybody please? Okay, so the thing is, from the dog and from the cat, there is one thing is very different. That is, the fur and the sound are of course different. Whisker is also different. So these three are the distinct characteristics among the others. Though others has separation, but not that much separation. So if I have a dog here also, and we want to select the features, so we want to uh, extract the features and select the features, all the extracted features might be very similar. However, from those similarities, we need to find out what are the most identical ones. So that is how we can get the feature selector. Okay. And then when you pass to the, sorry, when you pass to the classifier, then uh, yes. So when you pass to the classifier, then actually we pass these three to the machine learning classifier. Okay. Now we can do these combinations. First, we can take whisker and fur. Then we can only take whisker. Then we can take whisker and sound. Then we can take sound and fur. So these every combination. So whisker and fur, whisker and sound, sound and fur, only whisker, only fur, only sound. This way we can pass to this machine learning classifier and get the output. Okay, and we can measure like how the machine learning algorithm is performing. So we need to give the run 1, 2, 3, 4, 5, 6, and 7 run we need to give, because with 3 features also we need to give a run to the machine learning algorithm. Now there is a valid question. Okay, that question is, okay, I told this 9 times, 67 times we need to run the algorithm. However, now an interesting problem occurred. Okay, so that thing is, we develop the machine learning algorithm, and the machine learning algorithm can receive 3 inputs and give 1 output. Now, as I told, one time I take whisker, one time I take far, one time I take sound, then I take whisker far, whisker sound, far sound, then I take whisker far sound. So here I have only 1 input. Here I have only 1 input, 1 input, 2 inputs, 2 inputs, 2 inputs, 3 inputs. So do you think every time we need to change the machine learning model from scratch? So 3 times we need to build the machine learning model. So this is not the way actually. We cannot build this machine learning model 7 times. Okay. This is 3 times. This is not feasible. So what we do is, we have 3 inputs. It's fine. So whisker, far and sound. We kept the values into whisker. These values are over here. And then for far and for this sound, we some random values we fill it up. So how these random values comes? There are a lot of techniques. So these random values, maybe we can add some random data points from all the feature values we can analyze, because when you normalize the data, you see the mean, standard deviation, statistical analysis we can do. And from those statistical analysis, suppose let's see the whisker probability density function is like this. These are the PDF curve. No, this is not PDF curve, the histogram distribution curve from all the features. And then for far, the curve is getting like this. And maybe from sound, the curve is like this. So we can replace those values with some intersecting values, or we can get those values from the outlier values. Okay. So if you take those values from here, the classifier, what is the classifier performance? Classifier goal. Classifier always tend to see, okay, what are the most separable values? So if we have values like this way, the classifier will struggle, and we need to find out some good classifier to separate these things. But if we have very distinct ones, suppose here are some values, here are some values. So these cases, they don't need to see these. They can just draw the line and say, okay, this is A and this is B. Okay. So these values, the random value, should be determined in a way it should not have any impact onto the result of the classifier. So if you give some random values over here, from here, random values, so these values actually cannot give the machine learning algorithm any sense to classify very distinctly. So to classify very distinctly, only the sense should be given by this whisker. Okay. For cat whisker, maybe the curve is here. For dog whisker, or maybe some other animal whisker, the distribution is here. So that means the cat feature, whisker feature space is here. The dog feature whisker feature space is here. So it can now classify this thing. However, for far and sound, if those data points are here, or maybe the data points are here, it should not impact the machine learning decision over here when we are replacing those values. Similarly, when we have two values, whisker and far, and sound we will not take, that time these values not will be not none. These values will be some random values, random initialization, whatever. And then we kept these values, and then we pass to the machine learning classifier to see how it give us the decision for the classifier. So like this way, every time we can do, and we can check how is the performance get updated, and we can come to some decisions. Okay. So one thing I need to mention, all the combinations, if we want to take, suppose we have several features, A, B, C, D, E, F, G, and these are our features, selected features. Now from here, maybe B, C, D we have selected. These are not selected, these are extracted features, and these are the selected features. And from B, C, D, now we need to permute and combine all of these and see the performance. So while doing the feature selection, we are not relying on all the possibilities like Dr. Strange, because it is very expensive computationally. So we reduced a bit. Maybe for that cases, we can use the decision tree based classifier. One solution, this is not the perfect solution. This might be one solution to bring the explainability into this feature extraction part or selection part. And then from the selection part, when we pass to that black box of machine learning classifier and getting the decision, okay, then we are creating this permutation combinations and checking out how the performance is varying with a certain parameter we are calling Shapley values. And we are trying to understand, okay, my machine learning, my selection based algorithm is thinking, okay, B is the most important feature, and then C, and then D. Is my machine learning algorithm is thinking in that way? The same example I previously gave. Okay, I am thinking Messi is playing the best one, or CR7 is the best one, or Bhutia is the best one. Is my black box is thinking in the same way? If my black box is thinking in the same way, then I can trust it. Then I can say, okay, my machine learning model thinks like I think. I can trust it. So in future, any data point I can give and I can check, okay, these are the output because of this decision. Previously, we used to say, okay, B is the first important feature, C is the second important feature, and D is the third important feature. And we pass to the machine learning class and we'll say, oh, we get 100% output. Okay. However, how can you tell? Machine learning classifier is also thinking B is the first important feature, C is the second important feature, and D is the third important. We don't know. We don't know. Like the example of the child. The child might think, okay, maybe good example is whenever you tell a child, okay, this is a cricket ball or this is a ball. You may say, okay, it is a ball because this is round in shape, but the child might think, no, 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 this is red and red means ball. It can think in this way. So we need to trust. We need to give our trust into them, and we also need to validate this thing. So now let's go to the importance of bearing fault diagnosis. Uh, so till so far, I told why bearing is important and what is the necessity of explainability embed into that machine learning based models to classify cat or dog, whatever. Now let's compile all the stories together. So bearing importance of bearing fault diagnosis. So first thing is, in the world, lot of energies every day we see we are wasting energies, there are energies everywhere. Okay, so we need to be very sensible for energy consumption. And there are source of energies. These are like coal, gas, or fossil fuel. From these resource areas or these sectors, we can get a lot of energies, right? And these energies, these type of industry, coal industry, oil industry, gas industry emits a lot of carbon dioxide every year, and this is creating greenhouse effect. So greenhouse effect is creating our life miserable every single day. We are facing this thing. And as I told, among these heavy industries, consumes 50% of energy, right? And I gave the example of car at the very beginning. However, that is the small picture to give the audience a overview. Okay, why we need bearing fault diagnosis, but the real scenario is here. Why every year the industry is spending a lot of money for bearing fault diagnosis or this type of fault diagnosis mechanisms, because heavy industries consume 50% of energy, and the component motor is reliable for 80% of energy consumption, and from inside of the motor we have this bearing. Okay, and the motor fault, 79% occurred for mechanical and 21% occurred for electrical faults, and from mechanical faults 69% are responsible for bearing faults, and others are responsible for 10%. So if we focus on this bearing, okay, then maybe we can try to attempt to solve the 69% of problem out of the 79% of mechanical fault problem. And as I told, from bearing, how we detect the fault, we collect the signal. So signal collections can be varied from different technologies to technologies. That is another matter of discussion for another day. However, vibration analysis is very popular. So, and lot of publications you may get for vibration analysis based techniques. So with the vibration signal, I actually in my PhD, I tried to solve the problem. I also used acoustic emissions and electric signals. However, those part we tackle through the signal processing. Rest other part is very similar. So signal processing part from mechanical domain and electrical domain, you can analyze those data based on those domain expertise, and then rest of the part is this explainable AI, deep learning, machine learning, whatever you want to use, you can use. So the problems into the existing approaches, as I told, this bearing we get signals, and from those signals a lot of faults occur. Different is bearing can rotate very faster, bearing can rotate very slower, so its speed changes. So if its speed changes, the fault condition also changes, so it is totally inconsistent. Okay, for example, you can think like this way: if you have the ceiling fan or the table fan, sometimes the fan rotates very slowly, right? So suppose the fan blade has some defect, and if you give the speed 1, so the rotation has one characteristics, one type of. If you give the speed 2 or 3, the rotation characteristics totally change. So that means if the rotation characteristics change, the acquired signal also changed. Okay, so suppose for fault into the blade 1, we give speed 1, the signal we receive, that is totally different from speed 2. When we give the fan speed 2, the signal we are collecting, this 2 differs a lot. Okay, so there is inconsistency. And then if we extract the features, as I told, from the selection based mechanism or so many advanced algorithm, if you use, you can go to the explainable AI part into that sector, but it would be computationally expensive. So this has also a problem for the explainability. And also, as I mentioned, the machine learning algorithms have this problem. So this three part has the issue. Okay, these three parts has the issue, and for this fault speed A, speed B is differing. This part, maybe to solve this part. Okay, to solve this part, we need some kind of signal processing expertise. But suppose some expert came on and say, okay, I can tackle this thing. Okay, these are the data. You take this data, then we now know these two part we can tackle, and we can try to find out some solution how we can solve these two part. The way I said, these are not the step, these are not the only way. People are still doing the research, and there are a few libraries into the Python called Lime, Sharp, or kernel shop, or maybe gradient descent. So this type of libraries will help you to tackle those issues. I said, okay, every time we need to randomly generate some values and replace those values. So this thing you don't need to think about it. But these libraries can help you to solve these issues. However, if anyone wants to get his or her hands dirty, so they can come and they can think, okay, how I can utilize with some new ideas and come into place. So in that way, if you bring up some solution and your solution uh, uh, becomes very good, then into the publication or into the industry, your work will be very much acceptable. And that actually we expect from the next researchers, or also if I by myself want to talk, I will also want to give myself time to go into that direction. So how I can come up with some new ideas. So this is the thing, and some assessment I want to talk. Uh, that is, if the algorithm is very simple, then actually the complexity does not arise much. So suppose you take a very heavyweight algorithm, maybe neural network, maybe support vector machine, this type of algorithms. So to shuffle up those values, to run these algorithms from the very scratch is very difficult. Not difficult means like computationally expensive, critical. But the thing is, if you extract, select a lot of features and then just reduce those features, bring into a very smaller set, and then try to bring the explainability, then maybe if your feature has very good separability, you can use KNN algorithm. It's very simple, and in my entire life I like KNN algorithm very much. Also, you can go shift from KNN to DBscan. So this is a very good technique which can be a good competitor with KNN, and you can use that for bringing the explainability. However, however, if you need very faster performance, the industry comes and said, okay, your professor maybe come to say and says, okay, I don't need explainability. You are spending a lot of time. I need some kind of faster performance. Then you should compensate with that. You don't need to go for the explainability. You just take all those data. No need to do the feature extraction, pass to the CNN, DNN, or whatever new recently the point transformer comes, or this quiznet lightweight neural network based architectures, pass to those and it gives the result, very surprising results. So you're getting faster results. Okay, so you need to think whether you want to be into that explainability zone or you want to faster performance. Okay, and that is the thing. If you ask always why, then go for the explainability. But this type of algorithm needs multiple runs, as I told, combinations you need to make. And it is not like that all the time you select only 3 features. Sometimes from 10,000 features, you can select 10 features or maybe 100 features. Then these combinations get more and more. So how you can tackle this? This is also a challenging part, and a lot of researchers are trying to solve these issues. However, for bearing fault diagnosis, explainable AI, it's very new. People use this thing for predictions. Suppose in the stock market, the stock prices fall down. Why it has fallen down? Due to Donald Trump, who was not the president, or COVID-19 came and destroying our life, or black fungus came. This type of justification for prediction market, we use this explainable AI. However, for the classification also, this thing is necessary, and I was very lucky because with my research group, when we published the paper, it was first of its kind. So I hope actually this paper will get a lot of attentions, but this is quite new. So we don't know, but we tried to explain the paper in an in-depth manner, and my thesis is also based on that philosophy. when we need the explainability and when we need faster performance. So this is the paper. This is open access article, so anyone can read this. An explainable AI-based fault diagnosis model for bearings. Also, if you need to read my thesis book, I can also give you that. And hopefully in some future session, if I have the chance, I will show how you can use that libraries I have used extensively for developing this model. And thanks, that's from me. Thank you. And if you have any question, you can email to me. And that's it. Thanks a lot.
Well, thank you, Junaid, for your presentation. And I would like to ask from audience if they have any questions.
So any queries from girls? You can unmute yourself and ask. Girls, any queries?
Okay, Junaid, I think like they don't have any queries at the moment. Probably if they have, like they can text you or mail you
Yes.
regarding queries.
Yes,
Yes.
sir,
Okay.
you can ask.
And we are trying to plan to have some kind of researchers get involved into our program.
Okay.
And what we basically do is research on the fault diagnosis. Don't think this is a mechanical kind of thing. This both belongs to computer science. What can this belongs to computer science. So
Mhm.
it's, machine learning algorithms is not like defined to only one particular kind of field. It can be
No.
applied to anywhere.
Yes.
As part of a computer science student, you can apply that one to any field,
Yes.
not only limited to computer vision or some kind of image processing or something. Okay, so if anybody finds any interest in this field, they can ping either to me or like you can intimate to your teaching staff or like Kalyani ma'am. So we can try to plan a project, a working project for this, and then we can continue.
Yes, sir, sure. Okay.
Ma'am, if nobody have any questions, maybe you can wind up this meeting.
Okay, sir. Yeah.
Yeah.
So, on behalf of CSC department, I would like to thank our today's speaker, Mohammad Junaid Hassan sir, for explaining the participants about the necessities of explainable AI for developing ML models, and also explaining the how to extract the features, feature selection, and little bit of genetic algorithm and all. Thank you very much, sir. Thank you for coming forward and sharing your knowledge with our young budding engineers. Hopefully, we'll plan some more sessions with you, sir, in future. Thanks once again. Thank you, sir.
Thanks a lot. Thanks a lot. Have a great time and stay safe, everyone, for the COVID. I hope everything gets normal again and we can roam everywhere. Thanks a lot.
Okay, sir. Thank you, sir.
Thank you.
Sir, I'll be sharing the recording, sir.
Yeah, ma'am, it's not a problem for me.
Yeah, yeah.